Hello, welcome everyone in Math Simplified by HM channel. Today we are going to see the solving simultaneous equations by the determinant method Cramer's rule. In our previous video, we have seen the mathematical landscape for solving the simultaneous linear equations. The first one is elimination method, second one is substitution method, third one is graphical method, and the fourth is now determinant method. We have seen three methods previously. I request you to see each video 2 to 3 times for understanding and mastering the method. Now we proceed to our determinant method. Let us take the system of simultaneous equations which 6x minus 4y is equal to minus 12, 8x minus 3y is equal to minus 2. Now we will see step by step determinant method to solve these simultaneous equations. Understanding the Cramer's rule. Use determinants to solve their linear systems. The standard form required here. Please write each equation in the form of a1x plus b1y is equal to c1. Now consider our system. First equation is 6x minus 4y minus 12 and second equation is 8x minus 3y is equal to minus 2. Now comparing with this a1x plus b1y is equal to c1, we get a1 is equal to 6, b1 is equal to minus 4, c1 is equal to minus 12, a2 is equal to 8, b2 is equal to minus 3, c2 is equal to minus 2. Now step 1, calculate the determinant D. The determinant D is the coefficients of x and y written in vertically column and rows form. A1, A2 are coefficients of x, B1, B2 are coefficients of y. Now we will calculate D. We have D is equal to 6 minus 4, 8 minus 3. Calculating the D, remember that cross multiplication is taken from top corner to bottom and from bottom to top, and find that we have minus the product. First D is equal to 6 into minus 3 minus in bracket 8 into minus 4. Please remember to put the bracket or parenthesis while solving negative multiplications. Here we get 6 into minus 3 is equal to minus 18 because we know that plus and minus term when we product it we get the negative number. Minus 8 into minus 4 in bracket minus 32, minus 18 minus into minus again become plus, so minus 18 plus 32. Solving we get D is equal to 14. Now steps 2, calculate determinant dx. Replace the x column, that means a1, a2 with the constants c1, c2. Our determinant is that D is equal to a1, b1, e2, b2. Originally we have this determinant 6 minus 4, 8 minus 3. Now we replace this 6, 8 by constant minus 12 minus 2. Now we will find dx. Dx is equal to in bracket minus 12 into minus 3 minus in bracket minus 2 into minus 4. Solving we get minus 12 into minus 3 plus 36 minus in bracket minus 2 into minus 4 plus 8, so 36 minus 8. Simplifying we get dx is equal to 28. Step 3, calculate determinant dy. Replace the y column b1, b2 with constants c1, c2. Our determinant a1, a2, b1, b2. 6, 8 minus 4 minus 3. So replacing this minus 4 minus 3, we get dy determinant as 6, 8 minus 12 minus 2. Simplifying we get 6 into minus 2 minus in bracket 8 into minus 12. We get dy is equal to minus 12 minus in bracket minus 96. Simplifying, we get minus 12 plus 96. Further simplifying, we get dy is equal to 84. Now step 4. Solve for x and y. Here x is found by dx upon d. So x is equal to 28 upon 14 because we have dx as 20x and d as 14. Simplifying, we get x is equal to 2. Similarly, y is equal to dy upon d. So y is equal to 84 upon 14. So y is equal to 6. Thus, the solution of given simultaneous equation is 2, 6. Verification, quality control. Let us substitute 2, 6 back into the original equations. Equation 1, 6x minus 4y is equal to minus 12. 6 into 2 minus 4 into 6 is equal to minus 12. Simplifying this again, we get minus 12, which is equal to RHS minus 12. So this is the correct statement. We substitute 2 and 6 in second equation. 8x minus 3y is equal to minus 2. Simplifying, we get 6 minus 18. Further simplifying, we get minus 2, which is equal to minus 2 the right hand side. So this statement is also true. Thus the solution satisfies both the equations. Now understood the key takeaways of determinant method. First, structure. Arrange equation in standard form, that is x plus by is equal to c. Signs. Watch for negative signs during cross multiplication, AD minus BC. Formulas. B is equal to A1 B2 minus A2 B1. X is dx upon d. Y is dy divided by d. Consistency. If d is equal to 0, the method fails. The lines will be parallel or coincident lines. The zero trap when d is equal to 0. If determinant d is 0, we cannot divide by it. First case, no solution or parallel lines. When if a1 upon a2 is equal to b1 upon b2 but not equal to c1 upon c2, this condition satisfies, then the lines represented by simultaneous equations are parallel lines. If you have a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2, then the lines are coincident lines and thus have infinite many solutions. Geometric interpretation. We have seen graphical method for solving the simultaneous equations. Here this line is 6x minus 4y is equal to minus 12 and this line is 8x minus 3y is equal to minus 2, which intersect at the point 2, 6. So algebra meets geometry. The solution xy is the exact point in space or in Cartesian plane where the two lines intersect each other. The double negative danger. Please remember that where we make the most common error. Minus 18 minus into bracket minus 32. Subtracting a negative becomes positive or addition. So minus 18 plus 32 is equal to 14. Proportional tip. Always use parentheses when substituting negative numbers. Why use Cramer's rule? We have seen all the four methods for solving the simultaneous equations. Now we will see each its positive and limitations. Elimination substitution method is good for integers, but it is messy with fractions because it takes a long time to calculate. Also, sometimes we have to take the least common divisible LCD. Also requires intuition because while solving elimination or substitution method, we have to check each and everything carefully. Graphical method It is a visual, easy to understand, but imprecise for decimals. When there is a decimals, we are unable to plot the points, and so we can't do the lines. And it is also time consuming, as we have to first find the coordinates, then we have to plot the lines, and then we have to see the point of intersections. Cramer's rules. It is algorithmic and systematic. Very simple. No guessing is required, as in substitution method or graphing method. It is a computer friendly. That means you can easily calculate the values and find the d, dx, dy. Avoids intermediate fractions. This means that while we are solving by substitution or elimination methods, we get the subtract intermediate fractions, and that can be avoided here easily. The mathematician behind the method. Gabriel Cramer, who life period is from 1704 to 1752, a Swiss mathematician from Geneva, received a doctorate at the age of 18 years. Published his method in 1750 in Introduction to the Analysis of Algebraic Curves. So this method is called as the Cramer's rule. But note that this system is first discovered by Colin Maclaurin, but Cramer popularized the notation. So this is called as the Gabriel Cramer rule. Simply it is now termed as the Cramer rule. Now we will recap the Cramer's rules once again. You can term it as a Cramer's rule formula sheet. The determinants T A1 A2 B1 B2 is formed by the coefficients of x and y variable. Dx, here coefficients of x are replaced by C1 C2 and the determinant is C1 C2 B1 B2. Dy is equal to A1 A2 C1 C2 where coefficients of y are replaced by C1 C2. The solution is x is equal to dx upon d, y is equal to dy upon d. Condition is that valid only if d is equal to 0. Thus, we have seen Cramer's rule in detail. Please share this video to your friends. Like this video. Please subscribe my channel to see or to get my new videos. Thank you once again.